4.2a, circumcenter. So you might hear that word and be like, what is that? This is a brand new word to us, but we're still talking about some things we know, which is, again, we're going to be talking in this lesson about perpendicular bisectors. So we know those. They cut a segment in half at a right angle specifically, right? Now, what the circumcenter is you can draw 3 perpendicular bisectors in a triangle because you have 3 sides in a triangle, right? So I can perpendicularly bisect every side of the triangle. So that's what you see in this picture in your notes. You've got, if that's my right angle, this is one perpendicular bisector. I could keep it going. Notice that if I line this up here, I am bisecting these sides at a right angle. That doesn't mean that my arrow here is going to go through my angle. Because right away you can see if I'm doing that, I'm not creating that right angle, right? I'm kind of veering it off. So perpendicular bisectors don't come all the way across to the opposite angle. They just cut at a right angle one of the sides in half. So again, that might mean that it kind of veers off a little bit this way. So this is a perpendicular bisector. I have one here and I have one here as well. What ends up happening, what's kind of cool about this, is that the point they intersect at, which again we call the circumcenter. So this point right here, whoops, this point right here, well, I made that kind of big, is what you would call the circumcenter. So if you want to label that, we would call that point D is the circumcenter. And we're going to talk about in a bit why that's called circumcenter, where that comes from. What ends up happening is something kind of magic. This point ends up being equal distances from all 3 angles. Notice these distances here were all marked congruent. Now, those are not the perpendicular bisectors. Those are specifically the distances to the angles. These 3 are my perpendicular bisectors, which is where those right angles come from, right? Perpendicular. These 3 are the distances to the circumcenter, from the circumcenter to the angles. Now, this is something that you'll see in your homework, so make sure you refer to this when you guys are doing your homework. Again, we call this the point of concurrency. That just means where they cross, right? To be concurrent means they're all intersecting at the same point. So what ends up happening with this is it can actually be inside, outside, or on the triangle, depending on the kind. So add this in your notes. You can see it in the picture, but in a acute triangle, the circumcenter will be inside. That's to do with the angles. If I were to draw my 3 perpendicular bisectors, the circumcenter would end up being inside my triangle. Notice in a right triangle, my circumcenter ends up being on the triangle side, or on a side, we should say, right? An obtuse triangle, it ends up being outside. And again, that has to do with the angles and what I'm about to talk about next. So those are questions on the homework assignment, so make sure you're referring to those. If I draw my 3 perpendicular bisectors, it can be sometimes inside, on, or outside the triangle. So this is not in your notes, but kind of just follow along here. These 3 pictures are just what I copied. They're just these 3 right here. So why do we call it the circumcenter? So it's the center of what is called the circumscribed circle. If you've done art before or some like 3D design type things, you might know what a circumscribed circle is. It's a circle that touches all 3 angles in a triangle. So notice what happens here very magically. And again, circumscribed circle, circumcenter, yeah? So when I draw a circle on Smartboard, I create a point and then I pull downwards and it keeps my center. If you guys can see that dot, I'm pointing at it. That dot is the center of my circle. So wherever I click and pull, wherever I first clicked is the center of the circle. So what's going to happen here is I'm going to click on my circumcenter. My circumcenter here is P. Oops. So I'm going to click, and what I'm going to do is I'm going to pull out until I have a circle that touches all three angles. So notice what happens here. Whomp. What? It's magic. Notice that. Where's my pen here? I made a circle that is centered at the circumcenter, and it perfectly touches all three corners of the triangle. So you call that a circumscribed circle when it's outside the triangle. Yeah, and it kind of goes all the way around. This is a popular thing in graphic design, having a triangle inside a circle. And again, the magic is going to happen just like this. I'll do it again. Here is my circumcenter where they all cross. I'm going to click and drag until I create a circle big enough that it magically touches all 3 points of my triangle. Notice again, here's my circumcenter, the center of this circle, and it magically touches 1, 2, 3, all corners of my triangle. One more time I'll show on this last one. Here is my circumcenter. I'm going to pull and drag and create a circle big enough, and it's going to magically touch all 3 angles of my circle. Here's my circumcenter, the center of this circle, and this circle magically touches perfectly 1, 2, 3. So that's why it's called circumcenter. It is the center of a circumscribed circle. So you don't necessarily need to know that, but a lot of kids are like, why in the world, where does circumcenter come from? That's where it comes from. So let's go ahead and look at example 1. We're just going to do 2 things here. So the magic again of what happens here is that, 2 things. Let's go back. I'm sorry, I forgot a couple things. Let's look back to those pictures, sorry, on the front page of the notes. So the magic again of what happens is that the distances from the center, the circumcenter, will all be equal. Careful to note that I'm not saying these ones are equal with the right angles. In fact, they don't look equal, right? It's the distances from this point to the angles. Now, reminder that, because this is nothing new, but because I am drawing perpendicular bisectors, that also means that all of my sides are cut in half. So this side is cut in half right here. 1, 2, 3, 4. 1, 2, 3, 4. And this side is cut in half right there. So that is still true because we're dealing perpendicular bisectors. So when we're looking at this picture, before we even find what we're looking for, I want to talk about what segments are congruent. So again, the magic here is from my circumcenter, which is D in this case, that's what we call the circumcenter, to the angles. Those sides are congruent. Those pieces, I should say. So here is DR. DR is 1 distance from the circumcenter to the angle. DT is 1 distance from the circumcenter to the circle, to the angle. And then what's the last one? DS. So all of those are the same magically. These pieces right here are not going to be the same, or at least they're not guaranteed to be the same. We don't know that. It's always the ones from the center to the angles. Now again, because I'm dealing with perpendicular bisectors here, I have lots of pieces on my sides that will also be congruent. So this line right here cuts this side in half. So these pieces are congruent. I can't name them because there's no letter here in the middle, but I'll mark them. I've got these 2 pieces, right, from here to here and here to here. And then go ahead and mark that other side as well. How do you mark that other side? Well, I've got this piece, 1, 2, 3, 4, being congruent as well. So we have halves along the outsides, and then we have those 3 in the center. So because of that, this makes it very easy to find DR. If we want to find DR, what you have to realize is, what is DR equal to? And in fact, we know what DR is equal to. Do you guys see what DR should be equal to? Well, DR is equal to DT, which is equal to DS, and I know DS. So these 3 will be the same Therefore, dr is also 9. Very easy again of knowing what matches together. Boom, there's our answer. But we just have to know what matches. Let's try it again on the next one. Now, this next one, I'm actually going to ask you to change it. 2 things, so pay close attention to how we're changing this. 1, I'm going to ask you to not find QN, find PB. Now, if you look at your picture, B is not there. I need you to add it. They did not label these points, and I want you to. So if you guys could add on your picture for number 2, an A here at this point, a B, and a C, then we can find PB. So let's go ahead and find PB. Where is PB on the picture? Take a second, point it out. Well, here's PB. So we just need to know what PB is equal to. PB is equal to something in this picture. Now notice that PB is on the side of my triangle. And we know that all of my sides are cut in half, right? Because I've got lots of perpendicular bisectors here. So all of my sides are cut in half. So if we notice what we have here, I want you to kind of take a second and think. Using just this fact, I can know what PB is. Take a second to see if you know. What is PB? Well, the whole side here is 48. I know that my sides are cut in half, so these 2 pieces have to be the same. And therefore, PB has to be half of 48, because that's my whole side and it's being cut in half. So what is that? 24? Yeah. That's our answer. So 24, 24, that would get us to the 48. Now I want to remind one more time, also I'm going to erase this stuff. Whoa, not highlight, erase please. What segments are congruent? So take a second. Again, because we've got perpendicular bisectors here, what we know is from the circumcenter to the angles, those pieces are congruent. So just like last time, I want you to name the 3 distances from the center to the angles. Those 3 will be the same. What are they? Well, here is center to the angle is PQ or QP. Center to the angle is QM. And center to the angle is QN. Those will all be congruent because of the magic of what happens with the circumcenter. Now again, I will specify that we just said these are also congruent, these 2 pieces are congruent, and these ones are as well, because of the nature of the fact that my sides are being bisected. But we knew that already. We knew that a bisector cut sides in half. The new thing is that when I draw all 3 bisectors, where they cross at, that's what we call the circumcenter. And I will be equal distances from that point to my angles. So when we come back in class, we're going to practice a little bit more. Again, guys, as I said with this unit, it keeps happening where things are equal, things are equal, things are equal. It makes our life a lot easier. You just have to know what matches with what things are equal to each other.